In this video, we're going to go over how to find a limit where we have to rationalize a numerator. Say, what? What does that mean? Well, let's take a look at it. First of all, you've got a limit. And as in the past, we shall do now, which means if you've got a limit and you're evaluating it, take the value you're taking the limit to, or that you're approaching, and plug it into the function. See what you get. So let's put 3 into this thing and see what we get. So that's going to be equal to the square root of 3 plus 5, or just 5 if you're speaking normally, minus root 8 all over 3 minus 3. And let's see what that leaves us with. Well, 3 plus 5 is 8, of course. The square root of 8 minus the square root of 8 all over 3 minus 3. And that simplifies down to 0 over 0. And if you haven't seen me do this already, what I like to say is, if you get 0 over 0, look further. This, again, is the indeterminate form. And so there is something we can do to manipulate this limit to get it so that we can actually find it analytically. So what is that thing that we need to do? Well, I'm going to rewrite it. We're going to get the limit as x goes to 3 of the square root of x plus 5 minus the square root of 8 all over x minus 3. And what we're going to do is something that you've been taught to not do, which is put a radical in the denominator. Why? Well, it's not that we're putting a radical in the denominator. It's more that we need to get rid of the square roots up here. So when you see those square roots, you got to get rid of them. We're going to multiply by what is known as the conjugate, which is this plus that. And that's going to create something very cool. So I'm going to multiply the top by the square root of x plus 5 plus the square root of 8 instead of minus. And then whatever we do to a numerator, we must do to the denominator. If we do not, then we are just changing the value of this fraction. And that's just not allowed. Can't do that. So you get the square root of x plus 5 plus the square root of 8, all in the denominator. So how do we know to do this? You'll know to do this because you'll get 0 over 0 and you'll say, how do I manipulate this? By multiplying by the conjugate, watch what's going to happen. We're going to end up distributing. So you get the first terms, and the square root of anything times the square root of that same thing is equal to what's ever inside of the square root. So that's going to be equal to x plus 5 is what we'll get. So I'm copying down the limit. This times this is x plus 5. Then what you'll notice is when we do the outer, which is root x plus 5 times positive root 8, and then the inner is root x plus 5 times negative root 8, those are the same products. You get this times root 8, and then the negative of the same thing, they'll cancel out completely. So I'm going to write that out just to have it. But normally, I don't show this work out. I would just do it mentally. So we get root x plus 5 times root 8 minus, and now we get the inner parts, root x plus 5 times root 8. They're two of the same terms. And then root 8 times root 8 is 8. And of course, there's a minus times a plus, so it's minus 8 all over. Now, here's a very important idea. There's no reason at all to distribute these terms to the x minus 3 because our goal is to manipulate the numerator, not the denominator. So I'm going to leave everything as root x plus 5 plus root 8. Okay, as I mentioned before, this term and that term are the same things but opposites. So they'll cancel out to 0. And we're left with, keep copying the limit, we haven't evaluated it yet. The limit is x goes to 3 of x plus 5 minus 8. 5 minus 8 is x minus 3. Why am I getting excited about that? Well, we will see that shortly. Just copying the numerator from the last step, you get the square root of x plus 5 plus the square root of 8. All right. Well, so first things first, these are going to divide out here. The x minus 3 is gone. Peace. See you later, x minus 3. So they divide out. And now we're going to reevaluate the limit at this point. You've got 1 in the numerator from the division here. This turns into 1 and then multiplies by that to keep it. And that's going to allow us to take a limit. We've gotten rid of the factor that caused 0 over 0 when 3 was plugged into it. And that is a beautiful thing. So I've got root x plus 5 plus root 8. What I'm now going to do is plug 3 into this. That's going to give me 1 over the square root of 3 plus 5 plus the square root of 8. And that equals, well, this is root 8, that's root 8. You've got root 8 plus root 8, that's 2 root 8s. And could you simplify that further? Sure. Yeah, you could break down root 8 if your teacher needed you to 1 over 2, and then root 8 is 2 root 2, and that equals 1 over 4 root 2. But I'm fine with an answer like this. And no, you don't need to rationalize this. A lot of calculus teachers are going to tell you you don't need to get rid of the square root in the denominator. That's fine. It's just like when you learned improper fractions were okay, like 5/4 in 6th grade, it was just terrible if you didn't write it as 1 1/4. Well, now it's totally cool, 5/4, right? Radicals will be okay in the denominator as well as you get into higher levels of math. One thing I wanted to mention just in terms of the thinking of all this is, yeah, this is kind of a crazy problem. You look at that and say, how am I ever going to remember to do all this? Well, here's the secret. It's really not a big secret. It's the idea that you've got one main step to do, right? You've got to multiply by the conjugate. That will get rid of the radicals. Once you do this step, the rest of this is trusting your algebra. You're not memorizing how to do it. You're just simplifying. And then you're eventually plugging in values into your limit like you knew from before. That's it. So it's a big leap for you when in math you realize this is all stuff I know how to do except for one little new step, rather than thinking of it as one whole new problem, which it's not. All right, y'all, that was fun. You know I can't wait till the next video. I hope you feel the same way.